Hey, Will, welcome back. And this session, we are going to learn about how to compare the two sample data with each other. So here are the tests which we use for the two sample comparison. If you are comparing a before and after situation and the sample size is equal, data is normally distributed, we use pair t-test. In case you don't have a before and after situation or sample size is not equal, so alternate option to the pair t-test is the two sample t-test where you compare the mean value. In case you wanted to compare the variability between the data sets in form of standard deviation or variance and data is normally distributed, then we'll be using the f-test. Or if you are comparing the variability between the two data set and data is not normally distributed, then we use the Leibniz test. If data is not normal, you are comparing the median of the data, then Mann-Whitney test, or you are comparing the defect rate of the data set to data set, then we use two sample Poisson rate test. Or in case you are comparing the defective rate of proportion, then we use the two sample proportion test. So we'll be learning all these tests one by one. So let me start first with the pair t-test. So pair t-test we use when you are comparing the two data set before and after situation and the sample size are equally distributed and data is normally distributed as well. So the basic principle how the pair t-test work, see you will have the point of estimation of both the data sets. Suppose this is the mean for the data set 1, assuming here, and you have a mean of the second data set, maybe here, like this. Now, if we see these two values, they are definitely different from each other. So I'm assuming the average value of this, which is orange line, is average value of different from the green line, which is A and B. But these are the mathematically different because mathematics works at the 100% confidence level, but statistically, they may be same, as the statistics by default we take as a 95% of the confidence level. So how the statistics will perform? Statistics will always compare the data set with the confidence interval. And confidence interval is your point of estimation and plus or minus margin of error. So suppose margin of error is saying that these value may range from suppose x to x plus 1 and x minus 1. So this value is x, a, right side is x plus 1 and this side is x minus 1 because plus minus 1 is your margin of error. The similar way, if you look for the green line, so green line confidence interval may be like this, right? So now in case your confidence interval is overlapping anywhere with each other. So sample 1 data, suppose this is like this, is overlapping with this, and sample 2 data coming like this, and you see there is a overlap, right? So this overlap can be anywhere between these two data sets. Suppose if I say that this value is ranging from here to here, this is overlapping, and till here, wherever they overlap. So in case it overlap, they are same up to here. Or in case they does not overlap, like as between there is a gap created here, that means they are different. On that principle, these two sample, so pair t-test will work and all the two sample comparison will work. So simple, how you will get the p-value. So if two data set confidence interval overlap, then it's a null hypothesis and your p-value will be greater than 0.05. And if two data set confidence interval that does not overlap, then it's a alternate hypothesis and your p-value will be less than equal to 0.05 at 95% confidence level. That's the principle works here. Now let's take some data. If I generate, suppose you have the before improvement, you have a process, and you have the after improvement or after training. Let's say here is your production, before and after production you have, and in your team member, somebody you sent him or her for the training, they were doing around transaction 30 to 35 per day. Now after improvement, you send them and the transaction a bit improved from 32 to let's say 36 transaction per day they are doing. Now you wanted to validate post improvement. Is there any significant difference, statistical significant difference? So what you have done, you have collected the data for the last 25 days. So you have the before improvement data and you have the after improvement data. Now you wanted to compare, is there any significant difference or there is no significant difference? So when I look for the before and after data, and if I just compare the average value, let's say mathematical difference. So average of before data was around 32.28 transaction and post improvement, this is moved to 33.76 transaction. So there is an improvement. Approximately how much? If you see the difference, 33.76 minus 32.1, 1.48 difference. 1.48 you are improving from 32.28, which is around 4.5% difference we can see here. But this 4.58% difference is statistically significant, yes or no? We have to validate. So for that, we will be using the pair t-test in Minitab. So what I do, I just copy this data and I will be pasting in the Minitab. Though there is an option available in Excel as well. Let me see that how to compare this data. So if I go to Excel in the data and data analysis, in data analysis, you will see many of the statistical tests are there. So here, pair t-test for two sample means you can see, I just select this, click on OK. So this is asking for the variable range. So my variable range before improvement data is this up to here, and after improvement data is this, which is up to here. You have the labels as well. Alpha label is 0.05 and output of this data. Maybe I wanted to see, let's say here in this column. Done. Hypothesize mean difference. I don't have any value, let it be. So this is not mandatory and just click on the OK. And now you have the output as a pair t-test is here. So what does it indicate? Before improvement, we have the 32.28 mean. After improvement, 33.76 mean. Variance, number of sample, Pearson correlation, hypothesized mean difference 0, degree of freedom 24. And what we'll look for, we'll be looking for the p-value. So p-value on the one tail, which is only one side, is 0.00169. P critical, P2 tail value, and P critical 2 tail. So what we'll be looking for? We'll be looking for here the P, which is T 2 tail value, which is less than 0.05, which means it says there is a statistical difference between these two data set average. If the same thing I wanted to check now with the Minitab, so how we'll do? We'll go to the stat options in Minitab. And first thing we should be checking the normality of the data. We know to perform the normality, we use Anderson-Darling test. So when you have two data set together, Anderson-Darling test, typical Anderson-Darling test, which is here in this option, will take only one data set to compare the normality. But if you want to use two data set at a time, so you go to the graph option, go to the probability plot. In probability plot, you select single because each data set is in a single column. Click on OK. Select you both the data here. Now go to the multiple graph option and you can say, let's say in the separate panel of the same graph, two graphs you will see, and you need to just read the p-values. So looking at this data graph, what we got after comparing the pair t-test, these two data set for the normality assessment, I found both the p-values are less than 0.05. You can see here, this p-value is less than 0.05. This value is also less than 0.05, which means data is not normally distributed. So whenever data is not normally distributed, ideally you should be comparing the median. But for the learning perspective, let me compare the mean of these two data set with the help of pair t-test. So I'll go to the stat, basic statistics, and here is the option for the pair t-test. You click on this pair t, select your sample 1 before, sample 2 after. No need to worry about anything, let it be, and just click on OK. So what does it indicate? It will give you the p-value as in 0.003. If you remember, we compared the same p-value in Excel sheet as well, which I was telling we'll be looking for this p-value pair. T is less than expected T, two tail, right? So 0.003, the same p-value we got here, less than 0.05, which clearly indicate that there is an alternate hypothesis, because your null hypothesis says your actual mean is equal to hypothesized mean. And alternative hypothesis says that your mean of the sample 1 is not equal to the mean of the sample 2. So here p-value being less than 0.05, there is a difference, and we can prove that the statistical difference means the mean of 33.28 is not equal to 33.76. That's how we'll be comparing the pair t-test. Thank you so much, people, and I will see you in the next session.